So let's do the review. So very first thing that we need to do is to draw the parent graph first. So I just want to do a reminder. The parent graph here is y equals 2 to the x. See? So if I put in, these are my x value, my y value, then I have -2, -1, 0, 1, 2, 3. If I plugged in -2, I would get 1/4. 1/2. If I plugged in 0, I would get 1. If I plugged in 1, I would get 2, then 4, then 8. So if I'm going to do this, here, here, and then 8 would be somewhere up here. So this is my parent graph right there. And it's getting closer and closer, and I know that I can't really make it look like that there, but that's okay. So if I'm looking at this, this is a growth. The domain, all real numbers. Now I'm going to wait on the range for a minute. Y-intercept, that means I'm going to plug in 0 for x, and I get 1 minus 1, so y equals 0, so the point 0, 0. So I'm going to plug that point 0, 0. Okay. So when I do 0, 0, then I'm going to look at this. So we went down 1. Well, isn't that what that says right there? Is that it's going to go down 1? So all of these points are going down 1. So I'm going to come down here, go down 1, go down 1, and up here, go down 1. Okay? So now this is getting close. Oh, I should go this way. It's getting closer and closer to that -1. So y is going to be greater than -1. Okay, let's look at this next one. Okay, so this one is still growth. The domain is all real numbers. This says that I'm going to go to the left 3, and then I'm going to go down 5. Okay, let's look for my y-intercept. My y-intercept is y equals 2 to the 0 plus 3 minus 5. So that's y equals 2 to the 3rd. That's 8 minus 5, so that's 3. So the point 0, 3. So I'm going to plot that automatically. Oh, I didn't, sorry, I have to draw my parent graph real quick. So this is here, this is here. Okay, so, oops, there we go. So I know so I'm going to take each one of these points, I'm going to go to the left 3 and down 5. So from this point right here, I'm going to go down to the left 3, 1, 2, 3, and down 1, 2, 3, 4, 5. And from this point, I'm going to go 1, 2, 3, down 1, 2, 3, 4, 5. From this point, left 1, 2, 3, 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4. Oh, nope, here. There we go. And we know it's going to go through there. So then it's going to get closer and closer to here. And it's going to go up like so. Okay? So it's not going to be lower than -5, but it's going to be greater than -5. So y is greater than -5. Okay, so let's look at this one. The parent graph on this one is different though. The parent graph on this one is 1/3 to the x power. So that means, oops, that is a decay, all real numbers. Y-intercept, -1/3 raised to the 0 plus 1. So that's -1 plus 1. So y equals 0. Okay, so now, oops, I should be doing, let me do this in this color. I meant to have two different colors. Okay, so if I was to do a t-chart of this, -2, -1, 0, 1, 2. So if I plugged in -2, that's going to flip the 1/3 upside down to be 3 and square it. That would be 9. This would be 3. This would be 1. 1/3, 1/9. So let's plot those. So -2, 9. So that's going to be way up here. 1, -1, 3. We're going to have this, and then we're going to have 1/3. So this is getting closer and closer. Okay, I know it's not perfect. That's okay. This one says that I'm going to reflect over the x-axis, and then I'm going to go down. Oh, nope, I'm not going down. I'm going to go up 1. Okay, so I'm going to do the reflection first. Let me do the reflection first. So if I did the reflection, I would have this, I would have this, and this. So it would look like this. So that would be my reflection. But it says that it's going to go up 1. So from this that I have, it's going to go up 1. So I'm going to do this here. I'm going to do this here. And everything is getting closer. Okay, like so. So this is going to be y is less than 1. Okay, so this one over here. To go here, I either add 4 or I multiply it by 3. Here, I add 12 or I multiply by 3. Oh, look at that. We multiply by 3, so my ratio is 3. This is exponential. This one doesn't go up by the same amount, either multiplying or adding. So that means that this one is neither. This one right here, we just did this one up above, so this one looks like so. If I have a t-chart of the, I have, 1/4, 1/2, 1, 2, 4. Okay, so what happened over here? It reflected over the x-axis. So when it reflects over the x-axis, the negative will go out in front of the rate. This one, we're using the same parent graph. 2 goes in, we'll get 4. Okay. Oops, I missed the point. We'll put it over here. Okay, guys. I didn't mean that. If I look right here, the change between those two is 1. Then the change between these two is up 1, 2 over. So it goes If I look at this point to this point, that's 1. And then if I look from this point to this point, that's 2. So those are the same points as these points right here. So what is it done? It is moved to the right 1, 2, 3 times. So it's going to be y is 2 to the x minus 3. Okay, so this one, again, is the same one. So I'm going to draw it again. Oh, be careful. These are going up. This one's going up by 2. This, or 1, this is going up by 2. So 0, this would be here. 1 is at 2, and 2 is at 4. Oops, 4. 3 is at 8. 4 is at 16. Okay, so this is going to get closer and closer there, and going to go like so. Okay, so we know that it flipped across the, what is that called? A y-axis, so we know that that's happening. So it flipped. So now it's here, it's here, it's here, and it's here. So what did it do? Well, let's see, it went up from 2, it went up to 6. So that's up 4. So did all of these points go up 4? Did all the points go up 4? Let's see. Okay. I don't like when it's halfway. Okay, so this is halfway. And that's halfway. So these, it helps if I know, you can see what I'm talking about. This point to this point is it's going up by 1. Do you see how it went up by 1? And then if I was talking about this point to this point, it went up 1 whole line section. This to this, that would be 1 whole line section. Okay, so we're going up from, oh, that's not 2, that's 1. So it went up 1, 2, 3, 4, 5. It went up 5. So that means that this is going to be a plus 5. So y equals that right there. Okay, this one. Again, we have the same graph. Okay, let's make sure what's it going up. It's 2, so that means this is here, this is here, this is here. And where are the markings? Okay, so you have to remember this is up by 1, this is up by 2. Okay, so this part right here went up by 1, this part went up by 2. So this point right here corresponds to this point right here. So what did it do? It went to the left 1, 2, 3 times. So it went to the left 3. How much did it go up? It went up 1, 2, 3, 4 times, and it went up 4 times. So y equals 2 to the x plus 3, and then a plus 4 out there. Okay, this one. Oh, this time it's so -2, -1, 1, 0, 1, 2. So that's going to be 1/25, 1/5, 1, 5, and 25. Okay, so here and here and here. Okay, so how far is it from here up to here? It goes up 4 and over 1. Okay, so if I'm looking down here, I have this point right here, and I have this point right here. Okay, that point there, this point here. It went up 1, 2, 3, 4. It went over 1. So those are the corresponding parts. So oops, I did not mean to write in marker or highlighter. So I have 5 to the x. It moved down. It went 1, 2 down, so minus 2. Okay, so we're going to go over here. Again, this goes here and this goes here. So we're looking to see what it did. Okay, it flipped over the x-axis. So that means there's a negative out in front. So if this flips over the x-axis, that means we have this point right here, and this point right here. Okay. Now, let's see, where does it go through 2 points? It goes through this point right here and this point right here. Now, from here to here, 1, 2, 3, 4. We still have 4. We still have going over 1. So that still corresponds to these 2 points right here. So how far up did we go up? 1, 2, 3 times. So we went up 3 times. Okay, this one. Again, we have this point right here. We have this point right here. Okay. We have this point here. We have this point here. Notice nothing happened to the y values. It didn't go up or down, but it happened to the x values. So it's 5 to the x minus 4. It moved over 4 times. And this one. So this one, we have a point here. We have a point here. Okay, this we have a point here and a point here. Oh, look, those 2 points are in the same spot. What did we do? Well, first of all, one went from a growth to a decay, so that means that we need to flip it so that it's going this direction. So that means y equals to the negative x. And what did it do? It moved this way, moved that way 2 times, so minus 2. Okay, over here. So reflects over the y-axis. So if something reflects over the y-axis, it goes up here. Okay, if it goes up, that means that we add 5. This one, it says a reflection over the x-axis, so that means that there's a negative out front. And there's a horizontal compression. So compression, remember that horizontal means it's up by the x, but remember anything that's horizontal, we have to flip it. So that means that this is going to turn to a 2. This one, we have y equals 5. We have x. It says that we're going to go left 6. So that means left 6. It says down 4. And there's a compression of 4. A vertical compression. Okay, so the next one says horticulturist can estimate the number of hybrid plants of a certain type, and they will sell based on the parent function y equals 2.5 to the x. Suppose a new facility starts with 4 of these plants to hybridize. which can be modeled by this function. Describe the effect of the graph as it relates to the parent function. Well, first of all, is it a growth or decay? It is a growth. What is the y-intercept? So the y-intercept to start, the starting one would be, if I plugged in 0, that would be 0, 1. But we're talking about this one right here. If I plugged in 0 for, it has f of x. So if I put f of 0 equals 4 times 2.5 to the 0, f of 0 is going to come out to be 4. So that's a 0.04. So we already know that it moved up 4. Now, the description also has to be that there is a vertical stretch of 4. Relevant domain. Okay, so if we're talking horticulturists, we're talking about hybrid plants. Can we have negative plants? No. So that means x has to be greater than or equal to 0. And when x is 0, we have 4, don't we? When x is 0, we have 4. So that means y has to be greater than 4. Okay, next. It says write an exponential function. So I've been given 2 points. Y equals ab to the x. So my y value is 1.4 equals ab to the second power. Then we have 5.6 equals ab to the fourth power. So on this one, I'm going to divide both sides by b squared. And I'm going to get a equals 1.4 over b squared. I do not know why I switched what sides they were on. So 5.6 equals 1.4 over b squared times b to the fourth. So these cancel, and this becomes squared. So I have 5.6 equals 1.4 b squared. And if I take 5.6 and I divide it by 1.4, I'm going to get 4 is equal to b squared. So we just want the positive. So b is equal to 2. So if I take this and I plug it back into, I don't know which original, I'm going to do 1.4. Oops, I should do this in 1.4 equals a. My b value is 2. We're going to square it. I love how I should have done that. Whatever. There we go. So I'm going to get 1.4 equals a times 4, divide by 4. 1.4 divided by 4. I'm going to get 0.35 is equal to a. So what is my equation? My equation is y equals 0.35 times b. And there we go. Okay. Oh, I totally went over into the, let's do this. There we go. So here, I'm going to do 10.4 equals AB to the first power, and I'm going to do 665.6 equals AB to the fourth power. So on this one, I'm going to do 10.4 over B equals A. Over here, I'm going to do 665.6 equals 10.4 over B times B to the fourth power. That's going to cancel out, and I'm going to get to the third power. So now I have 665.6 equals 10.4 B to the third power. I'm going to divide both sides by 10.4. So 665.6 divided by 10.4, and I'm going to get 64 equals b to the third. So b to the third, so sorry, 4 to the third power is 64, so 4. So we're going to plug that back in. We're going to come over here to 10.4 equals a, and then we just found b to be 4. So we're going to take 10.4 and we're going to divide it by 4, and we're going to get 2.6 is equal to a. So our equation is going to be y equals 2.6, 4 to the x. This one, okay, I have 48 equals ab to the third power, and I have 3 equals ab to the first power. I'm going to solve this one. So 3 over b is equal to a, and plug that in. 48 equals 3b times b squared, or b to the third. Cancel those and get squared. Should do that in a different color. So 48 equals 3b squared, divide by 3, get 16 is equal to b squared, so 4 is equal to b. And I'm going to plug that in to this equation. So 3 equals a, is that right? Yeah. And my b value is 4. Divide both sides by 4. So 3/4 is equal to a. So my equation is y equals 3/4, 4 to the x power. Okay. Hello. This is the 5th time I've tried to do this part of the video, so I hope it works. What is the initial amount, growth rate, and domain and range? A population, f of x, so that's people, after x years, that means it's time, may be modeled by this equation. This right here is our initial value. This right here is going to be our growth rate. Our domain. We're talking about years. You cannot have a year in the negatives. Our range. Well, if this is the smallest x value, we've got to plug that in. So f of 0 equals 2 times 3 to the 0 power. Well, that's 2 times 3. No, it is not. It's 2 times 1, so it's 2. So y is greater than or equal to 2. We are skipping this one. Whitney invests $3,000 in an account earning 4.5 interest that is compounded annually. How much money will be in Whitney's account after 10 years? So that equation is A equals P parenthesis 1 plus R over N T. So our starting amount, I don't know why I did that, equals the principal amount. How much did we start with? 1 plus. Now this says it's compounded annually. So how much does it get compounded each year? 1 time. So I'm not going to divide. My n value is 1. Anything over 1 is that same number. So I'm just going to put this. And then 1 times t is just going to be t. Now would I accept it as this right here? course, because it means exactly the same thing. Now, if I can get my calculator to work, then we're going to do 3,000 times 1.045 raised to the, and it says 10 years, and I get $4,658.91. Attendance for the local baseball games has been increasing by an average of 10% per year for the last few years. In 2018, the average attendance was 100 people. We're talking about people, boys and girls. So that means y is going to equal 1 plus our rate raised to the t. So how much did we start with? How many people did we start with? We started with 100 people. 1 plus, what's the rate? The rate is 0.10. We know what t they want, but right now that's what we have. Or you could write it as this. Now we're going from 2018 to 2022. That means my t value is going to be 4 years. So if I plug that into my calculator, so 100 times 1.1 raised to the 4th power, it comes up with 461.41. Well, guys, we can't have partial people. So it's only going to be 146 people. This next one wants us to write explicit and reoccurring functions. How about recursive? Okay, so here we go. Well, it's going positive, negative, automatically is not going to be arithmetic. So let's see. Negative 50 divided by 100. That's going to give us times by negative 1/2. These two times by negative 1/2. Yes. This times by negative 1/2. Oh, yes. So that works for all of these. So that means my ratio is negative 1/2. So a sub n equals a sub 1, which is 100, times negative 1.5 raised to the n minus 1. Remember, when it's talking about a sequence, you're starting with the first term, not the 0 term, so you have to have the n minus 1. So this is our explicit formula. So now we're going to write the recursive formula. A sub 1 equals 100. A sub n equals negative 1/2 times, I don't know why I wrote it like that, a sub n minus 1, so the previous term, if n is greater than or equal to 2. So the term has to be the second term. Then this one. Okay, looks like we're going down by 15 each time. So that means my d value is 15. So a sub n equals, where did we start? We started at 20. We went up by 15, n minus 1. Now, you could also write it in the simplified form of 15n plus 5. So either one of those would work for your explicit. Your recursive is the a sub 1 equals 20, where a sub n equals the first term, not the first term, nope. The previous term plus 15, and we're talking about starting at the second term. So that's our recursive. Same thing here. Add 2 add 4. Oh, it's not arithmetic. Okay. So it's also times by 2, times by 2. Okay, so this is going to be geometric. So that means my R value is 2. So A sub n equals the starting value, which is 2, the rate, which is 2, and n minus 1. So this right here is my explicit formula. My recursive formula has to be A sub 1 equals what? 2, where A sub n is equal to 2 times the previous term, and you have to start at the second term. This one. This is going down by 0.6. That's definitely going down by more. So that means I need to do 5.4 divided by 6. That's going to get me 0.9. So if I multiply it by 0, nope, not. Zero's in the wrong spot. Oh no, I was doing the right thing. This one, yep. I'm multiplying each one of these by 0.9. So that is what my R value is. So A sub n equals my starting value, my rate, to the n minus 1. My recursive formula, A sub 1 equals 6, where A sub n is equal to 0.9 times the previous amount, and we have to start at 2, the second term. There we go. So this next one. Now, I told you guys you didn't need to do the explicit formula for these two problems. You're just going to be doing finding the terms for those two. But you are going to be finding either the explicit or recursive for the other ones. So the first terms. So the first term is negative 2. So if I plug this in, 2 times negative 2 plus 5. So that's negative 4 plus 5, so that's 1. So I'm going to put a 1 in here. 2 times 1 is 2 plus 5 is 9. And if I put like 9 in there, that's 18 plus 5. That'll get you 23. 1, 2, 3, 4. Oops. Did I do that right? 1. 1 times 2 is... I did not do that right. I knew those numbers were looking a little weird. Let's do this again. Negative 2, that would be negative 4 plus 5, which is 1. Now, if I plugged in 1 here, that would be 2 plus 5 is 7. There we go. 7, that'd be 14 plus 5. 14 plus 5 is 19. That'd be 38 plus 5, 43. Okay. This next one. Our starting value is 3. And we're going to go up by a rate of 4. So, multiplying by 4 each time. So that'll get me 12. That'll get me 48. So 96. I think the next one... Oh, that is not. I times it by 2. 192. There we go. That looks better. and then times that by 4 and get 768. There we go. Now, I need to also write the recursive formula. So a sub 1 equals 3, where a sub n equals 4 times the previous term if n is greater than or equal to 2. Okay, so we're going to come over here. Tells us that 38 is where we're starting at. Tells that we're going to multiply by a half each time. So that'll get 19. 19 times, or divided by 2, it's going to be at 9.5. Since I've messed up so many times, actually going to divide or use my calculator. 4.75, then 2.375. Okay, so then I need to write my recursive. So, nope, my explicit. So my explicit would be, start out with 38, multiply that by a half, and raise it to the n minus 1. Okay, over here, let's see, we'll use pink. So my first term, so I need to plug in 1. If I plug in 1, I get 45. If I plug in 2, I would get negative 14. Negative 14 plus 52. And get 38. Do you notice how it's just going down by 7 each time? That's what this means. This is my D value. It's your slope. It's your D value. So you're subtracting 7 each time. So we would get 31. Subtract 7 to get 24. Oops, I did it again. 24, subtract 7 again, and get 17. Then if I'm going to write my recursive, my a sub 1 equals 45, where a sub n equals the previous term, subtract, oh, that was weird, subtracting 7, and that's if you start at n is 2. This one, it is in an explicit, or it's in a recursive. We need to write it in explicit, and we need to write the term. So negative 2, and we're going to subtract 12. So negative 14. Subtract 12, negative 26. Subtract 12, negative 38. Subtract 12, negative 50. So if I'm going to write my explicit, I have a sub n equals negative 2 plus, oh no, we're subtracting n minus 1. Now if you have it in the simplified form, it would be negative 12n plus 10. I don't know why I did that. It should be around both of those. And then last but certainly not least, we are starting at 13. We are negative 2 times 13 minus 3. So that's negative 26. Negative. That was weird. Negative 26. Minus 3. Why did I use a calculator for that? Negative 29. So then I would plug in negative 29 here and multiply that by negative 2 and subtract 3 and get 55. and take that and multiply it by -2 and subtract 3. Get -113 and take that and multiply it by -2 and subtract 3. 223. Okay.